Hi, I want to go back over this process of finding the equation of a line of best fit for a scatter plot. It seemed like it was a little bit difficult for some of us. So let's explore this process again, step by step. The first step, if I want to find the equation of the line of best fit, is I need to draw the line that I'm talking about. I don't want to do this tracing through the points. I'm not trying to connect the points. So that's the first no-no. Do not connect the points. We are not playing connect the dots. The second thing we want to do is if we're being told to draw an line of best fit, even if I see some amount of curve in the data, I assume that I want a linear trend. So I'm going to draw an actual straight line. So I'm not going to draw that, even if that's what I see, because that's not a straight line. So maybe that looks like a straight line that matches my data. What tells me that's a good choice? First of all, I notice that there's a rough balance of points above and below the line. But not just that, the points where I am above and below the line, I see a trend that moves along the same slope. So we notice that even the points that are above, they still follow that general slope. It's not counter to that slope. So it can help sometimes to see a line that would be a bad choice. I'll do it with a highlighter. So this would not be as good of a choice because I can see that it's above lots of points for small x and it's below all the points for large x. So it's not matching the trend as well, even though it still splits above and below decently well. I also wouldn't want something that goes much steeper like that for the same reason. Now it's too far below the points where x is small. So in this region, it's underestimating. And then in the region where we have large x values, it's a little bit of an overestimate. Again, not what I'm looking for. I want my line to match as well as it can everywhere. Okay, now I have a straight line. And here's the key thing I want to point out for you. I'm going to zoom this in a lot. I may have a scatter plot here, but I just need the equation of the line I see. So I'm going to find 2 points on my line. It does not even matter if the points I select on my line happen to be points that are data in the scatter plot. So I often like to just take values where it's got a really nice x that I can read or a really nice y. So I'm looking at this and maybe I say, okay, I'm going to select this point here. So I just read it from 100 so that I have x value of 100. I know that'll make my math easy. And then again, I want the math I'm doing to be as easy as possible. So I bet it would be easy to do the math if I now just pick a point that's exactly 100 units to the right. Another way to do this to make it really clean is if there's a grid that shows up in the chart, this one doesn't have a grid, pick 2 points on your line that are exact grid points. Here, I'll say, okay, this is the other point I'm going to look at where x is 200. So now that I have these 2 points, let's figure out the y's. So I just want to read across to get the y's. Those 2 points are going to describe my line. If I have 2 points on a line, I can get the slope. So I just need the y's as well. Okay. We're going to do our best. And as some students have mentioned, one thing that makes this hard is you are being a little bit approximate. So this always works out better if you've got more precision in your grid, more precision in the line you can draw. But for our sake, I'm going to name this point on the right 200, 800. And then the point on the left, I don't know, that's bigger than 500. So maybe that's like 520. just guessing, 100, 520. So if you recall when we did this problem in class, I probably had something slightly different. Every time you're just doing the best you can. So my line of best fit is the line I drew. And if we go over to my steps now, I've drawn that line and I have picked 2 points on that line. My first point is 100, 520. And my second point is 200, 800. I'm now going to use those 2 points to build my fraction. So I'm going to get my rise. That's the change in y's. Rise, y's, they rhyme. So I take 800, the larger y, minus the smaller y. And now because I started with the y for x2, I'm going to use x2 as my starting x. 520, or sorry. There we go. 200 minus 100. Remember, I chose that because I wanted the math here to be really easy. And we're doing rise divided by run. So my slope here is 800 minus 520 be 280 over 100. So about 2.8. So notice we're getting a value much smaller this time. I've got a slope that's a line that's a little bit less steep than when we did the calculation before. And it's also all based on rough estimates that are so hard to make. I just don't have the information to make a good estimate without a better grid. So my slope is 2.8. We've currently found the slope. So we know in our example that our slope is 2 8/10. And for instance, I had the point 200, 800 is on my line. My task, therefore, is to find the equation of the line. So the real thing I still need is b, because I know my slope is m. So I'm using my y equals m times x plus b equation. I'm substituting in. I know my y value has to be 800 and that my x value has to be 200. And I know I'm multiplying that x value by 2 8/10. And I'm going to add b. So 800 should equal 2 8/10 times 200 plus b. So now I do my multiplication. So I have 800 equals 2 8/10 times 200 would be 560 plus b. Now I'm going to subtract from both sides the 560 that so that I can isolate b. And I obtain 240 equals b. So my final equation will be y equals the slope I found, which is 2 8/10. That represents the fact that in this example, as I calculated it, for every increase by 1 pound in the mass of these crocodiles, I was seeing an increase of 2 8/10 pounds of bite force. So 2 8/10 x plus my b at 200. So that's an equation.